Well, good morning. My name's Kevin Witherstein. I'm a systems engineer with Cumulus Networks. I'm one of a handful of folks that work in the central U.S. Anybody in the room know anything about Cumulus Networks? No? All right, good. I guess that's why you're here, right? So how many know about white box networking gear? A handful, a little bit. White box servers? You know what that is, bare metal servers? Okay, so bare metal switches are about the equivalent of a bare metal server, except networking gear versus compute gear, kind of obvious. So when I say white box, there's like 3 different terms that we use for the same piece of hardware these days in this particular market. It's white box, bright box, some of them are kind of in between, and then bare metal is the third one you'll typically hear. So whenever you hear those 3 terms, they're pretty much interchangeable for the most part. So Cumulus, just kind of level set up front, is a network operating system for that white box networking gear. And I'm going to kind of walk you through exactly what that is. And please, oh wow. You know, this thing worked just fine earlier. Of course. Bear with me just a second. Good morning. There's plenty of seats in the front row. I'm that guy. All right, so kind of like I said, we're the network operating system for bare metal switches and /routers. It's a data center focused solution, and I'll kind of talk to some of like my ending slides. I've got a couple areas where we're going to branch out into in the future. About the company, started in 2010, and the founders are from VMware, Cisco type backgrounds. So there's a lot of compute knowledge as well as a lot of networking knowledge that kind of came together to bridge a gap between, I'm going to talk about web scale IT. So when you hear web scale IT, what do you think of? Any particular names ring a bell? Huh? Nutanix, okay. That's a new one for me. So I typically hear Amazon, Google, Yahoo, companies that are just making these massive data centers, right? Facebook's another one that's pretty prevalent out there. So our focus is really in driving that type of data center build, but enabling folks in the enterprise to actually use the same technologies and the same methodologies in the enterprise versus having to have these massive data centers to roll out these different approaches to data center networking. So the company, about 2 million plus ports deployed so far, 550 plus customers. So for a company with that many deployed ports and customers, and most folks haven't heard of us just because we haven't done a great job talking to people in the Midwest. So that's why I've been around for about a year now at this company. So we've been getting out and talking to folks and trying to let people know what we do, and hence why we're here. Merging technology, right? So 2010 founded, our first customer was a very large online retail outfit. So I think they have about 100,000 switches deployed using a derivative of our operating system on the switches. I won't talk too much about the venture capital, but the big key here is, as we go through the presentation, is knowing that there's 50 plus supported networking devices and 9 different hardware vendors that use our operating system on their boxes. So it should be kind of clear by now that we're the OS, the operating system, and not the entire switch /router. All right, so where do we play? Mostly in the public-private cloud, so data center, and then within the telecom service provider data centers as well. But we do a lot with government, higher ed, anybody that's kind of tracking to a Web 2.0 type of a methodology. We play really well there. So we're going to get into why here in a little bit. So benefits to using us. These are 6 different key areas that I'm not going to talk to each one. Reading off a slide is not exactly fun for anybody when you're sitting in the audience. So I'll kind of leave those up there for you folks to gander over. I'm going to focus first on a little bit of the TCO, so the total cost of ownership piece, and just kind of that's kind of the title of this whole presentation, right? Is faster, cheaper, all that good stuff. So I'm going to focus on TCO, and then I'm going to talk to some of the other pieces, the flexibility, efficiency, scalability, things like that, a little further on. So the first slide on TCO. This is a study that was done by JP Morgan, and you can see the PDF down here just to show that it was a report that was out in the wild. They take a look at their total cost distribution within their data center, and try to get an understanding of, okay, how much am I spending on compute, how much am I spending on networking, and how much is it costing me to operate those pieces. And so what they found was they were spending a lot of money on OpEx, and the networking and compute costs were about the same. So, okay, big deal. It's a chart that shows cost allocation. So what's the problem with this picture? And it's this piece right here. You want to spend more money on the pieces that actually deliver revenue to the company. You want to improve the company's bottom line. Therefore, the more you can enable apps, the more you have for compute, the more you're enabling the revenue. So the less you can spend on networking and OpEx, the better off the overall business should be for the IT spend. And so that's what they found is when they went to a more of a Web 2.0 implement, that's probably a legacy term now, Web 2.0, isn't it? It's kind of worn out after 5-6 years. No? Got some yeses, got some nos. So so anyway, that web scale IT is kind of the new, more in vogue way of approaching that terminology. They found that if they take that same model with automation and taking that next generation approach to their networking, that they found that they spent a lot less time working on the devices and a lot more money and time were spent on the compute piece, delivering actual revenue, generating applications. Make sense? Good deal. So I took the liberty to when I first started working here, I was like, well, this whole TCO thing, there's more than just a CapEx play. There's an OpEx play as well. So you got to really dig into some of the details to figure out, okay, where is the money going? How is it allocated? And how exactly are we saving anything when we go talk about automation and just delivering a different approach to networking? So I took our networking sample, and I took 2 vendors that I'm fairly familiar with, and I kind of stacked them up in a spreadsheet and started doing my due diligence on what are the price points for the hardware, the pluggables, the support and maintenance costs, and then how much does it cost to operate these? And of course, anytime you start talking about operations cost, it's a guessing game because my operations cost might be different than yours. So there's a bit of give and take on that. So we're just going to have to assume that my 20 some odd years of experience in networking is somewhat legit, and I have a fair understanding of exactly what operations looks like. So when you take all that into consideration, I kind of looked at, okay, let's start looking at it from a switch count perspective. And if you start out with a handful of switches, the cost delta is not that big. It is if you look at it, but if you're looking at it from the overall scheme, it's not massive when you compare 10 to 100. You start looking at 100 switches, your operations and CapEx costs add up pretty quickly if you've got a pretty good sized delta on each individual device. So that's my TCO pitch. And I always love this slide because it usually generates a whole lot of, okay, show me the details. And I love to do that, but in 30, 40 minutes, we're not going to really have much time to do so. So if anybody has questions on that, we can definitely break out later and talk about it. So that was the TCO bit of the 6 different advantages, right? So here's 3 key areas on the CapEx we already hit on. The people that really care about this mostly are going to be your execs. Some management level folks might care about it because they've got a certain budget to hit. Business focus. So increasing agility. This is a key tenet for web scale IT. Being able to drive delivery faster. Being able to iterate and make improvements faster. So that whole process is enabled through having an operating system that actually can be driven differently than we've done so in the past. And then IT focus, just giving you a better platform, easier to manage, and better performance metrics than we've seen from networking equipment in the past. All right, so how do we do this? So you've kind of seen a transformation in the data center over the last 15 or so years. I think virtualization really kind of drove a lot of it. x86 drove a lot, virtualization kind of fell behind that. And then you're starting to see, we unlocked the compute layer, right? So you don't have to buy a Sun switch, I got switch in the brain. You don't have to buy a Sun Microsystems device. You don't have to buy an IBM device with a keyboard and a mouse. When you buy servers, now you're buying generic servers and putting the operating system on it that you want to use. So anybody still buying Sun servers? No? Okay. So the same kind of thing, unlocking that component to allow you to have choice, which in turn allows you to drive cost, is something that we're driving in the actual networking side. So now you have choice across the entire stack. So why is that important? Anybody volunteer to throw some apples at me? It's apple season, right? No? All right, so basically the networking, you could drive the cost down because now you've got a choice of vendors. If I can build my operations tooling for an operating system and interact with it the same way no matter what vendor's underneath, that drives choice in the same way you drive choice for compute. So, make sense? And if it's an open operating system that allows you to install applications, develop features, install features that you would otherwise have to wait for a vendor to deploy or actually come up with, that's another value prop. That might be a little bit far outside the norm, right? When's the last time anybody told you could develop your own features on a network operating system? It's just not normal, but it's good. So we get a lot of customers that actually go do that. It's a pretty interesting concept. So what made this all possible? Kind of all started with Broadcom. When they came out with this chipset, this system on a chip architecture, and they said, okay, here's a chipset, and what you do with this chipset is basically build a reference design. And you have a whole lot of people that go out and build these reference design switch and router devices, and you can see across the top, a lot of these folks use the same chipset. And now we've got and so basically, so this whole company is really driven around open networking. In other words, open up the entire box to allow for innovation and choice. So that's what kind of drives some of the cost metrics. But so now you've got one company that's kind of the bottleneck to the whole thing. So now I've got a chip manufacturer driving all the decisions that happen for everybody in this tool chain. So these folks over here are coming along as kind of the second vendor to have the chipset that allows a different system on a chip design. So that's going to start driving cost reduction here. So now you're seeing cost reduction at every point in the value chain. Whole lot of different vendors in that box. All right, so speaking of box, I was trying to get interesting here. You know, I go to a lot of DevOps conferences, and these DevOps guys are brilliant because they all come up with these they can do an entire slide deck with nothing but pictures and sit there and talk to the pictures and be real clever. I'm a networking guy. I'm not quite as clever, but I try. So I'm going to call this Pandora's box, this little networking black box over here. And basically, we're going to open up Pandora's box. So I actually had to go to Wikipedia and look up and see exactly what that meant. Okay, who's Pandora anyway? Besides the radio station, streaming radio station, right? So the black box appliance, basically you buy a box with an operating system on it, and you're given a list of features that it supports. So typically, if I'm making networking design decisions, I'm going out and I'm saying, okay, I got a concept, I got an idea how I want to build a network. So I'll say, okay, this is what I'm going to do. These are the protocols that I need to make this design concept happen. So once I've done that, I go and figure out, okay, what products are out there that have the feature set and the applications that I need to make my design concept come to reality. So that's how I pick hardware. Isn't that kind of backwards? No? So it might be. Let me keep going here. So basically what I'm going to do is I'm going to open up this box and I'm going to say, okay, pick your hardware, pick your software, and then pick whatever apps you need for the application or whatever design you're going after. And by doing so, you've kind of leveraged. So at first the concept might seem a little bit daunting because now I've got to go make a couple choices that otherwise would have been made for me. So this might not be for everybody. But people find that when you do have those choices and you understand the ecosystem, it plays all those value propositions, value points that I made earlier, they come into play pretty quickly. So cloud economics, pick your best of breed, you get scale, automation out of this, and you control the supply chain. So the supply chain means not just the box, but the pieces that plug into the box. So I'm going to give an over-under question. So if you were to buy a switch, let's say it was a 48-port switch, let's call it a 10-gig switch because you see those out there quite a bit. What do you think costs more, the switch or the pluggables that go in the switch? Optics, yes. So the great unknown, when you go out to bid for network devices, you might be buying something that's equivalent in price on the hardware platform, but by the time you get done populating that device, there's a big difference in the end unit, what the end cost is between them. So when you look at TCO, I encourage you to look at the whole ecosystem, not just the one piece. So in an operating system, we're not the only play here. We're just the best play here. How's that for shameless? Not shameless at all, right? All right. Questions? All right. So what is this network operating system looks? By the way, network. I should have made this like a trivia question. What's NOS? Network operating system. So what does it look like? If you really looked at a networking device, you're going to have what looks like a standard server from a look and feel perspective. If I were just looking at this hardware and say, okay, it's got a CPU, RAM, flash, power, and fan. Most devices have those components, right? The piece that's different is that silicon, that system on a chip piece that is key to driving the performance that you would expect from a networking device. So anybody can put an operating system on a server and say, hey, forward package from this port to that port. You can do that. The performance is probably going to suck. It might be okay for a couple of ports, but you're only going to get X performance out of it. So maybe 20 gig, maybe you get a really beefy server and maybe you get 40, but that's nowhere near 1.2 terabits. So what we're doing here is we're basically tying on the silicon with that compute-like platform to enable that hardware performance and still make this whole device look more like compute than necessarily networking gear. That way it fits into the automation and the whole data center tooling stack in a way that you can manage the whole stack with common platform tools, if that makes sense. If it doesn't, please let me know. So we are this piece in green. If you haven't kind of caught up on that yet, we're mostly a green company. Not green as in necessarily save the trees, just green as in that's our color. We have a mascot too, which is a turtle. Everybody loves turtles, right? Our turtle has a rocket on his back for obvious reasons. When you talk about fast networking, you don't want a turtle to be representative of your networking gear being slow. So you got to put a rocket on his back to make him appear fast. Anyway, so a little sidetrack there. So what happens? So there's the kernel piece, and then there's a user space piece. Our special sauce is this switched component, and what this is basically an application that runs inside of an operating system, and this is what we basically have to use to program the forwarding plane, so that you get that fast performance and you do your layer 2, layer 3 forwarding in the actual ASIC piece. So I didn't lose anybody yet, did I? I'm not going to go into any of the silicon stuff here, so I'll keep it fairly mid-level. So this is our special sauce. You've got an SDK or a software development kit that talks between this app and the silicon to make all that transactional stuff happen. So whenever I have a routing table update, I want to update the silicon, and this is the piece that takes care of all that. So you'll notice, anybody know what this stands for? No? Tired of the questions? Just get on with it. That's a symbol for DevOps. So if I want to install automation tools, automation agents, I can install them directly on the software. If I want to install, somebody's got to know what that is. Docker. If I want containers on the box, for whatever reason, knock yourself out. So a couple use cases for this. Let's say I wanted to deploy some management applications, and I wanted to do so in a way that says, okay, I want to replicate this across 100 devices or 1,000 devices, I don't care how many, but I want it to look the same for every single device. So I build a container with the applications that I want, and I deploy it to all those devices. So now I'm replicating and making the management pieces easier. So everybody checks in, and I don't have to reinstall the same apps 1,000 times over. I'm just installing a container. Pretty straightforward. All right. So the portfolio that Cumulus offers, so it all starts with the first piece, the network operating system. That's the piece I've been talking about. So from that, we have 3 derivatives. This thing we call RMP. $5 bonus for anybody who can tell me what an RMP is. All right, time's up. Rack management platform. So rack management platform is basically saying I've got an out-of-band switch that everybody's got out-of-band, well, most people have out-of-band management for a data center rack. You want to talk to the compute nodes, you want to talk to the networking nodes, somehow through an out-of-band connection typically. So this is a device that allows that to happen and puts all the IPMI tool sets right there on the networking device. So I don't have to have separate networking and compute for my IPMI pieces. It's all self-contained within that rack. it's been fairly popular. So it's something we talk about fairly regularly. Another piece that we have is this free download that we call Cumulus VX. And the VX is what we call a virtual experience. So it's a virtual machine, plain and simple, that you can download to do simulation, prototyping, testing, just getting familiar with the operating system. So it's as you can see in the highlighted green, our favorite color, it's prototyping is the highlight there. And then the last piece is we've got a routing stack that's in the operating system it's Quagga. So Quagga is an open source routing stack. A lot of folks are familiar with it. It's been around for a long time. So we've done a lot of improvements to it and then upstream our improvements so that the greater community can take advantage of it. And that's a routing component that we offer on the switching routing devices, but it's also something that a lot of our customers use on compute devices. And I've got a use case slide here in a little bit that I'll talk to what use cases that makes sense. Anybody have one out of the gate that they can think of? Routing on a compute node? Like high performance routing on a compute node? No? Okay, we'll get there. So our focus, I already mentioned this, it's in the data center. It's the switch route component within the data center. We are doing a little bit with campus networking in the future. Well, we do a little bit now. And then service provider, some of that service provider goodness as well. So but our core competency is right here in the data center. All right, so I'm working, one of these days I'm gonna make this thing so it actually will do like the twirl. It'll actually go in a circle. That'd be kind of neat, wouldn't it? Nice distraction. So Agile network deployments. One of the things about Agile's kind of one of those terms that's used a lot whenever you're talking to developers. And they have a concept of what Agile is, and then we kind of talk about Agile and networking as well. So we steal a lot of the DevOps concepts, at least their terms, because they're kind of cool, and try to apply them to the networking world. So one of the things that Agile does is it says, okay, I'm gonna come up with a concept, and I'm gonna design it, I'm gonna test it, and then I'm gonna deploy it. Whereas in the past, as a networking individual, I would go out and say, okay, here's my concept, I'll do my design, I'll go straight to production. I might do a little testing, spot testing, but I'm gonna roll it out. And that hasn't always worked out. Sometimes it works out, but it doesn't always work out well for us. A lot of times we spend trying to back out changes, retracing steps, lots of hours on maintenance windows. It's not always a fun experience. So if we had a way to actually constantly test, continuously test, integrate changes, and then deploy those changes once we've validated the integration works correctly, that would be a lot more efficient and probably a lot better for the business. So concept, design, test, and deploy. I know it's kind of sideways. I couldn't get these colors. So PowerPoint's a wonderful tool, but it doesn't let you do everything you want if you're not, anyway, I'm not a PowerPoint wizard. I wanted the test to be red. I don't want the deploy to be red. So I kind of adjusted the whole thing, if that makes sense. Anyway, so we call this net DevOps, this whole Agile development for this Agile network deployment. Net DevOps says, I'll take and I'll simulate this environment, this concept that I've got, simulate it. Once I've simulated it, I'll do my development, deploy it, and then deploy it to the production network. So I'm gonna deploy it to the prototype first, then deploy it to the production network. So what you'll see is all of the four different products that I talked about showing up in this one slide. The prototype piece being the VX. So once the VX is used for simulate, I'm going to deploy it to production on the data plane forwarding devices, which are the green boxes. The RMP, which is the awesome, thank you, rack management platform for that out-of-band management connection, and then the routing on what we call routing on the host, which is the routing stack on the compute nodes. Questions here? Concept foreign? No? All right, so this is me really trying to get clever. I have an idea, the whole concept thing, so I'm gonna take you through that whole Agile process. I have a concept, and I'm gonna basically, what does we as an engineer do? First thing we do is we go to the whiteboard, start drawing it out typically, right? Whiteboard, goes to Visio, whatever. So that's my design. And then once I get done with the design piece, I build a simulation, and in that simulation I'll actually test. And this is a handful of the tools that I use on a regular basis. A lot of the folks in our company use the same kind of tool set. We'll use Git as a version control system. And so those that have been in the software world, these are pretty common tools that you'll see them use on like any kind of a DevOps type of environment. So a version control system, and then I'll use a hypervisor and an orchestrator to build this whole simulation environment in a server or on my laptop even. So once that's built, I'll use an automation tool like Ansible to roll out whatever changes I want to roll out to the network in the simulation. Once that's done in simulation and I validate everything works like I expect it to, I then roll it to a deployment.
So what do you do the orchestration?
How do you do the orchestration? So the virtual box is basically just going to host the actual virtual machines for each one of these little icons is its own virtual machine. And then this orchestrator is given a list of, here are these devices, here's what I want them to do when they come up, or here's how I want them to interconnect to these different pieces. So whenever I tell this orchestrator, okay, go enable this environment, it goes and just runs it brings the whole environment up, just without having to interact with it at all. So it's kind of like so have you ever worked with Docker?
Yeah.
So you know with Docker, you've got a Docker file. This particular orchestrator has a Vagrant file, same thing. I say same thing generically, but yeah, you're specifying how you want it built. That's probably the best analogy I've got is Docker file to Vagrant file.
Something like if there's other software called Packer,
Yeah.
so it's just the same thing, template, creating images.
Yep. Yep. That's just one I haven't used. There's a lot of them out there for sure. All right, so the use cases. I'll check the time real quick. Got a few minutes left. So primary use cases. Web scale IT, I've kind of beat this one pretty good. It's efficiency, automation, just kind of driving towards that lower cost, faster deployment. Better operations tooling, just being able to deploy applications on the box. So I can use agent-based monitoring systems. I don't have to worry about SNMP anymore. SNMP MIBs, you only see and get information based on what the actual vendor has built to. You don't get access to everything that's in the box necessarily. You get a lot in some cases, but it just varies. APIs are kind of one of the ways to try to get around some of that. So now you got better interaction with the box. Maybe it's just APIs for programming. Maybe you can pull stats through APIs. I think it's vendor dependent. But if you've got an agent that you could put on the device and collect information and send it upstream to an outside monitoring panel, that's a lot more powerful than the way we've been doing things in the past. So container networking, containers by default typically do NAT to get to the outside world. What that tends to, and they spin up and spin down really fast. So doing networking in and out of a container, if you had an app on a container that you want to actually access from the outside world, can be a challenge. So there are a couple ways of addressing this. Most folks take and use container-to-container networking with overlays. So they'll build a VXLAN tunnel between different containers on different hosts to connect them. So let's say that you wanted to get to the outside world though, being able to advertise routing information from a host device seamlessly to the networking devices is one way to achieve that. And so as the containers spin up and spin down, that routing table is going to adjust as the IP addresses are assigned or basically brought online. So that's one of the things I talked about use cases for that routing on a host bit. This is where that fits really well. So another place is OpenStack networking. Anybody deploying OpenStack today? Thinking about it? No. So OpenStack is another place where routing on the host makes a lot of sense. OpenStack networking is kind of interesting because OpenStack can live virtually like a VMware networking can live virtually. So as long as everything's in the virtual domain, overriding an underlying network, excuse me, the world's all peachy, right? It's when you have to get off the virtual domain to the physical domain, just like with Docker, where things get to be a little bit more challenging. So we do some special parlor tricks with OpenStack by putting routing on the actual host to where it just makes networking with OpenStack easier and it's just a lot more seamless than it would otherwise be. And so a really quick case study, Midwest company, OpenStack overlay. The company had a mandate to go deploy OpenStack. They've got some public cloud usage. They wanted to build an internal private cloud for the components that they couldn't host in a public cloud. So they built their own OpenStack network, and what they were really looking to do is try to use as much open as possible to save as much money as possible. And this is just kind of a quick case study of how they built their private multi-tenant cloud and some of the technologies they used. 10 gig access to the servers, 40 gig spine. We try to talk them into 100 gig, but they're not quite ready to go there yet. When you tell people that a 40 gig switch and a 100 gig switch are the same price, they just kind of flip out and go, show me. So we're going to continue to have that conversation. And they went with a full layer 3 network. So it really simplified the network a lot because they don't have to worry about spanning tree outages and trying to trace layer 2 connections and things like that. So just a quick snapshot on those guys. So this is a little bit of market research, and I promise I'm almost to the end here. Open networking, just as a classification, if you look at it in comparison to the greater layer 2, layer 3 switching market in the data center, from a 1RU appliance perspective, it's the number 2 overall market share leader, which might catch a lot of people by surprise. It's a significant market. The problem is, it's a whole bunch of different vendors. So they all add up to one big number, but just not a lot of individual numbers. All right, so basically our key tenets, this is kind of my closing slide. It's an open, so our operating system is really driven about being open, being responsive, and being affordable.